Department of Computing and Information System to give me this chance. And it is really happy to get an idea from some student who learn in same university and who work towards the success of the university. Thank you, Anuradhaya, for organizing this kind of event. So today's the session is about Git and GitHub. Mainly, I'm focusing on Git. I will be go through all the basic Git commands that you need most of the time your university projects. Okay. First, I'm Isuru Abeywardana. I'm software engineer at Hmlet, Singapore. And also I am the first GitHub campus expert of Sri Lanka. You can find me in any social media account, social media platform using this this username, Isuru Abeywardana. Yeah, I used to have long hair, but I don't have that now. Okay, this is the history of the Git 0 to Hero sessions. I did first Git 0 to Hero session when I was in third year or second year N. I can't remember. It is in NSBM. Then after I cop up with my very good friend Omal, and I did 3 more sessions in SLIIT, University of Kelaniya, and Suburban University, my university. And we used to give a lot of swags, but sorry guys, you will not receive any swags this time because of this strange situation. We can't do so. Okay, why we did a Git sessions for other universities? So we when I was doing a Google Summer of Code, it is a global contest. Actually, I'm going to talk about Google Summer of Code at the end of the slides and at the end of this session, and how to contribute open source organizations. I will do a 15-minute session after this GitHub session, Git and GitHub session. When I was doing, actually, I'm a GitHub campus expert, as well as I'm a Google Summer of Code student. When I was doing Google Summer of Code, I understood that most of the Sri Lankan students, they don't have knowledge about essential Git commands, how the Git works, how the GitHub works, and how they need to interact with the open source organizations, and how to contribute to open source organizations. So that's why me and my friend Omar started these sessions. Okay, let's start the session. This is the very first slide of the GitHub that I'm going to start. Does Linus Torvalds know about Git? Who is Linus Torvalds? Linus Torvalds is the one who created the Linux kernel, and also he is the inventor of the Git. Git is version control system. You will, most of you guys know this. You guys, this is a kind of already known answer for your exam question. What is Git? Git is the version control system. So actually, what is the Git? Git is a tool that let you track your progress over time. Let's say you are creating a login screen using HTML and CSS. After you initiate the project, you can tag it, like you can name it. Okay, we have basic styles here. Let's say this is your, let's say we are creating a robo using a building blocks. Okay, we can say, okay, we have initiated the project here. In the version 2, we can say, okay, the leg of the robot is almost done. And we finish the leg here. And we attach the body and arms here. And here we can say, okay, the version 1 is ready. The whole robot is ready. This scenario we can apply to software development. Let's say, as I said before, let's say we are going to create a login. After we finish initial stylings, we can say, okay, we have initial stylings ready. After we finish API integrations, we can say, okay, we have integrated the API. Okay, or we can say, okay, we have connected the front end to the back end. Likewise, this is something we use to keep track of the progress of your software development. This is one of screenshot of my friend. Actually, I used to follow this way when I was in first year, second year, because when we are doing software development, sometimes we mess up with the code, and we can't go back. Sometimes we add new feature and break the code, and we can't revert the changes. So what we did was, we created a whole new folder and copy all the source to that folder, and name it like this: date and what we did here. Actually, we actually did this. Actually, we didn't have any idea about Git at that time. Okay. When we are talking about Git, we talk about two version control systems, two types of version controls: centralized version control systems and decentralized version control system. Git is a decentralized version control system, but you should know this: what is the centralized version control and decentralized version control. Centralized version control is something like this. They have a one central server, and everyone works on the same code. They get a copy, do the changes, and send it to the server. But there are some issues. When it comes to availability, let's say the server is down, and the other contributors, let's say other engineers, they can't send the code because the central server is down. So this is one of the main issue in centralized version control system. Okay. Git is a decentralized version control system. Yes, it has a central repository as the previous one, but we have our own copies. But and we get a working copy from that, and do the contributions. Let's say we have a repository. We have a copy of the main repository here, and we get a copy of that, and we do changes. We update our copy. This is our copy. And after we finish something, we push it to the server. Let's say the main server is down. It is okay. Still, we can contribute to the copy of the main repository we got here. So you might not understand this very clearly now. It is okay. You will understand the concept when we are moving forward. Okay. After this session, you should not use Google Drive to share your codes, right? I know some of you guys have no idea about Git, and when a lecturer asks you to send assignment that related to some coding stuff, and you definitely what you definitely do is you put it into a pen drive, or pass it to the or upload it to the Google Drive and send to the send to your lecturer. So you should not do this after this session. Okay, I will try to explain the Git system again in a different way. Git is like a working desk. It's like when you start work, you have a working area. Let's say you are doing a assignment. That assignment let's assume that assignment have a few chapters. After you finish your first chapter, you put it somewhere else. That means you are halfly done. After you finish the second chapter, you get those A4 sheets and put it somewhere else. After you finish whole assignment, you bundle it and you stapler it and put it somewhere else. It is like Git also something like that. We work somewhere. Let's say this is the working area. And after we put it somewhere else, after we finish it, we put it somewhere else. We call it staging area. These keywords are important. You will understand these keywords when we are moving forward. After you move these files to the staging area, then after you finish all these drafts, you bundle it. We have a different keyword in Git. We call git commit, and we put it into a repository. So I know some of you guys might not understand this. Let's go forward. Don't worry. Okay, when we are in Git landscape, we talk about two types of repository. Sorry, two types of repositories. One is local, one is repo. Local repositories. Okay, we have one more new keyword. What is the repository? Repository is, you can assume it is just a project folder. For now, you can just assume it as folder. Local repository. Local repository is you can assume it is the project folder that resides in your local machine. Remote repositories, it is another project folder that is in a remote server, maybe in GitHub, maybe GitLab, Bitbucket, or maybe a private Git server. This is two keywords that we are going to use in future slides: remote repository and local repository. Okay. I'm going to finish all these theories and I will do a demonstration. So I will be going little fast, but you will receive the recordings. So you guys can refer the recordings if you miss somewhere in the slide. Okay, we have a local repository. Let's say you are, I think you guys do C in your first semester. Let's say you have a C project. You do some changes to the C project here. After you finish the one task, after you finish one task, you stage it, and then after you commit it. Just try to memorize these keywords. We do changes, we stage it, we commit it, and we send it to the remote repository. Okay, how to move these changes to the staging area? This is how we do it with Git commands. First, we do the changes. Then we have a Git command called git add. When we use git add, it takes all our changes to the staging area. Then after, we bundle it with git commit. That means we can add the name. Okay, we have done this using C, and we can leave a meaningful message and commit it. I will show you all these things in the demonstration. Let's say your friend have a remote repository and you need to get a copy of that. Let's say you have do a group project. So we can use this git clone command to get the remote repository, which is your friend's repository. You can get it to your local machine. This is the command that we use for that. And let's say you have done some changes and you need to push the code to your friend's repository. You use git push. Let's say your friend has another new changes in remote repository. Let's say your friend added some more new features to your his repository and you need it in your local machine. You can use git pull to pull all these new features. Okay, that's how it works. Now, so far we learned these keywords: git remote, local repository, remote repository, git cloning, git adding, committing, pulling, and pushing. Okay, these are the basic keywords that we learned so far. Okay, I'm going to do the demonstration. First, if you are a Windows user, you need to go to this site git sem and you need to install it in your local machine to start with Git. It is the easiest way to do this. And I have already installed it in my machine. So I'm going to start the demonstration. It is just a exe file. You can easily install it in your local machine. So I'm going to take a repository to the local machine for the first time. Okay, I minimize this. I hope you guys can see my screen. Okay. Okay, I will remove this first. Okay. Okay, I have a repository here. Okay, this repository. I'm going to clone this repository. When we are getting getting a repository for the first time to our local, we use git clone. We have a green button here. You can copy this link. I will copy this link and go to my terminal. In your case, that git cm git what is the name? I can't remember. Git sem. It will give you the same kind of window. It is just like your command prompt. Okay, I'm going to clone my repository, this repository, git expert repository, to my local machine. Okay, here I don't have any folders here. I'm going to clone, git clone, and the URL I copied and enter. Okay, now you see it copies, it gets a copy, it gets a clone of that my repository. Okay, let's go inside. Okay, we have a readme file here. GitHub. I have a readme file. Okay, guys, I couldn't tell you before. You need a GitHub account to do this, do all these things. I'm using GitHub. You can use some other uh, repository, what to say, platform, some other platform like GitLab, Bitbucket, anything. But all these operations are same. The Git clone is same everywhere. Okay, I clone my repository for the first time. If I open this one, okay, I have this text here. Okay. What's next? Okay, we have another demonstration. Make a new repository and take a repository to the local for the first time and set up a user account. Okay, I will show you how we can do it. Okay, let's say we are going to start a whole new project. We can go here, click the plus button and new repository. Okay, first we need to give a name to our repository. Let's say SUL expert. Okay, I'm not going to give a description. You can give a meaningful description if you need. I keep it public. I don't need the README file, and I'm going to create the repository. Okay, actually, they will redirect you to the this screen. This screen contains everything you need to do to get your repository that is in the GitHub to your local machine. Okay, first, okay. First, I'm going to okay. Let me check the next slide. I can't remember what. Okay. I'm going to get this repository here, URL here, and I'm going to the terminal and git clone again. Okay, it creates a new folder. Actually, inside that there's nothing. Okay, now I'm going to create a text file here. So I'm going to open this folder in my favorite text editor. Okay, I was in the wrong folder. I need to go to SUL expert. And I opened that folder in VS Code. Okay, now I'm creating a file. Let's say I will readme.txt. You guys familiar with txt? I know you guys don't know what is the MD files. Okay, I have a file here. What we need to do is make changes and push those changes to the remote. Okay, I will add a sample text here. This is my first text. Okay. And now we are here. We can, unless these are basic Linux command. ls, now it shows you have a readme text here. ls for list items which are in the directories. Okay, I say git status. When I run git status, it shows what are the changes we have in our directory. It shows in red color. Okay, we have this readme txt. It shows it is untracked file. Yes, it should be untracked file because it is new. We created it just now. Now we use git add. Git add. When we use git add, it takes your changes which are in red color, and it turn to the green, and it takes all these changes to the staging area. We can do it in two different ways. We can use the file name, or if you have multiple files, if you need all these file changes in staging area, you can use the just full stop. And you can run git status again. You can use arrow keys to get your previously executed commands. Now you can see it turns to green color, and now it is in the staging area. Now we need to create a git commit. Git commit, here we have finished some task, and we need to give that give a name to that changes. Okay, we did changes, we put it into the staging area. Now we are going to make a commit. In this commit, I'm going to give a meaningful name. All the time you guys need to give a meaningful names for your commit messages. Okay, let's say I'm going, okay, I will say this git, this is the initial git git file, no, git repository. Okay, now you will see this strange message. Actually, you will not see this after the first time. Okay, because it gives this message because it doesn't know who you are. Actually, we need to configure this git git user account. We need to configure this git user account with these two commands. Okay, if you now we should have this git log, git commit in our git history. We can check this one, git log. Okay, I will maximize this little bit because it's not clearly visible to you guys. Okay, git log. When I run git log, it shows the history of my git repository. It shows the author is Isuru, and it shows my email in this way. This is not my email address. Yes, it gets the computer name as the email address. So when we push this to GitHub, it will not track our Git history in GitHub. So we need to configure our user account. So we need to use these two commands. I'm going to copy and paste. My username is Isuru AB. Okay. My email address is this Abeywardana@gmail.com. Okay. We're almost done. Let's do another change. Another change. I save it. Git status. Git status shows me the changes. We can see the difference of the previous file and the changes. You can use git diff. Now you can see, okay, we have changes here. Okay, git add. Actually, you don't need to run git status all the time. I run git status after every command because you guys can understand the flow. Okay, now we have our new changes in git staging area. Commit changes with my account. Now I check the git log. Okay, now we have our user account. The email has changed, but the previous history, we can't change it. There are ways to change. I will show you, but for now, we do not change this one. Okay, now we are going to push this code to our repository. We use git push origin master. You don't need to memorize all these things. These things are here. Git push -u. Yes, they have -u. There is something called upstream. You guys will get know this all these things. I'm not going to explain about upstream here. You guys can just copy and paste here and push enter. But I need to explain this origin and master. Origin is the what we say. Origin is this repository, and master is the master branch. I will explain about branches in future slides. So for now, just you can copy and paste. Okay, git push -u origin master. Okay, we have pushed it successfully. You can go to this page, reload. Okay, we have two changes here. Okay, so far so good. We have pushed the code. Okay, I couldn't tell previously. When you're pushing for the first time, it may ask your GitHub password. It will give you a pop-up box and ask your GitHub password. You can add the GitHub password, maybe username and password both. Yes. Okay, I have included all the commands that you need to follow. I will pass the slides to you, so you guys can follow these slides without any instructions. Next one, push your existing projects to GitHub. Let's say you have a C project or Java project in your repository, in your local machine already. Okay, I'm going to create a directory. Let's say my first project. Okay, ILS. Okay, I see my project here. I go to my project. CD means change directory. Directories are the folders. You should be familiar with these basic commands. Okay, I'm in this folder. I'm going to make a text file. Readme. I'm going to open this folder using my favorite text editor. Okay. This is my existing Git project. It is in my local computer. Okay, I have this project. Now I need this one in the GitHub in new repository. This one is we done with this one. We're going to create another one. Existing project. Okay, now I'm going to close this one. Okay, I'm going to look this one. Here you can see all the commands. Create a new repository on your command on the command line. This is how you can connect existing repository to the GitHub repository. Okay, I'm going to use this one. Git init. Okay, git init. Git init means we have to initiate the Git project here. Okay, we git init. If you can see hidden folders, you can see here hidden.git folder. It creates after this git init command. Then after, we need to add this remote origin. That means we need to introduce our GitHub repository to our local repository. Okay, this is how we do it. Git remote. Okay, we need a remote repository. Add it as origin. Okay, we are going to add it just like this. Okay, now we have connected. Okay, let's reload this one. Okay, but still we don't see any changes. So why? Yes, we have done changes. We have changes, but we didn't push it to the repository. We need to add this README. I will run git status. Okay, we have that change in staging area. Now I'm going to commit initial. Okay, I would say existing project. I run git log to see my git history, and I git push origin master. I'm going to commit to the master branch. Okay, let's see. Okay, we have the README file here. We have successfully uploaded our existing project to the GitHub. Okay, these are the commands that you need to follow. Okay. Next, Git branching. Previously, I told that we are going to talk about Git branches in the future slides. Here we are. Okay, just assume Git is a tree. Just like trees have branches, Git also have branches. Let's say one branch, but these branches have names. Let's say one branch, we have master, we name it as master. We can have another branch called testing. We can have another branch called feature one. Let's say we are going to create a new feature. So we don't do all the things in one Git branch. Let's say you have this code base here, your code base. These are the commits. Let's say here you need to add a new feature. Let's say we can apply this to real world scenario. Let's say you have a website and it has a login page, and all the things are working fine, and you wanted to add a forget password button. Normally logins have a forget password button, so you need to add forget password button. So let's assume this project has multiple developers. So you can't directly push to the master branch. So you need to create new branches. You need to get a copy of this master branch and do the changes and merge it. After you finish your development, you need to merge it. I will show you how we can do this. Okay, this is another very valuable advice. We never commit to the master. Yes, we did in previous examples, but in the actual world, in the industry, we never ever commit to the master. Okay, let's create a branch. We have master branch, we have some codes there. When we run git checkout -b testing, yeah, I know these keywords are very new to you. You will use to these keywords. Okay, git checkout -b testing. When we use this command here, it creates the same copy and name it as testing. Okay, when we use git checkout master, it goes to the master again. Actually, we are moving our workplace from master to testing. When we run git checkout master, it change back to master. Okay, I will show you how we can do this. Okay. Also, we can create multiple branches using this git checkout -b testing. It creates another branch called testing. If we run git checkout -b login test, and it makes another branch with the login test. Name is the login test. Okay, we can use this way also. We can run git checkout -b testing in same place. Here we have created two different branches. Names are different, but the copy is same. Okay. Okay. Let's say we have master branch, we have some code there, and we create a branch called testing, and we do some changes, and we need these changes in master branch. So we need to use this git merge command. Here we run the git merge testing. Testing is our branch name that we need to merge here. After we merge testing, it merges to the master branch. But the merge is actually not that nice. It actually works like this. Yes. If you have done something wrong, or maybe if you have done something that confuses the Git engine, it creates a conflict. Then it will show this kind of message, you can't merge it in GitHub. Okay. We call it merge conflicts. Oh, merge conflicts. It happens like this. In our previous case, when we were doing changes to the new branch, no one added a new changes to the master branch. Look here, nothing, no new commits. But in this example, when we are doing changes to the testing branch, some other developer has added some changes. Just assume this the developer 2 who added this commit changed same files and same lines of same lines that I have changed. So it confuses the Git engine and it creates a merge conflict. Okay, now I'm going to show you how we can resolve a merge conflict. Okay, I'm going to use the same project. I'm going to create branch 1. Now, okay, we can see the branch name using git branch. So it shows, okay, I'm in master branch. We don't have any more branches. Okay, we can create new branch using git branch. Okay, it should be branch. Let's say branch test. Okay, you can check whether it is created or not using git branch. Okay, we have created branch, but we are still in master. That's why it shows this asterisk mark in front of the branch name. To change to that particular branch, you need to use git checkout branch test branch name. When we run git branch again, okay, we are in the new branch. So I'm going to move back to the master branch. Git checkout master. Okay, we are in master branch. But we have run 2 commands to create the branch and move to that branch. So we can do it using one command. It is git checkout -b. -b means create new branch and branch 1. Let's see, git branch. Okay, we created the new branch and we move to the same branch at the same time. Then we need to do some changes to file and commit and push. Okay, I'm going to open open my code. Change one is here. Let's say change one from branch 1. I move to here, git status. We have the changes, git add, and I git commit, and I name it as changes from the branch 1. And I push it. Okay, we need to push them. Okay, we need to push them. Git push origin. We can't push the master because we are in the branch 1. So we need to push branch 1. Yes, but we didn't create any branch here. But if there is no branch in this name, it automatically creates a branch. We push it. Okay, it's almost done. Yes, let's go and reload it. Okay, now it shows we have 2 branches. Okay, master branch and branch 1. Okay, then what? Go to master branch, change the same file, commit and push. Okay. First, I will show you how we can merge it. I'm going to git checkout master, and I will show you branch. Okay, I'm in master branch. We have new changes in branch 1. I check git log. Yes, we don't have that change in our master branch. I'm going to merge this to our master branch. We are going to merge the branch 1 to master 1. Git merge branch 1. Then we run git log. Okay, we have changes we made in branch 1. Okay, to show you a git conflict, I'm going to do another change. I'm going to git checkout branch 1. and another change from branch. This is actually, I'm trying to create a conflict, so I'll be changing the same file and same lines. Okay, I have changes. I'm going to git add, git commit change 2 from branch 1. Okay, and I go to the master branch and I do the changes again. I do edit the same line in our branch 1. Also, we change the 4th line. I'm going to add another line from the master branch. Changes from the master branch. Okay, I save it and I git add it and I git commit it. Changes from master. Okay, now I'm going to merge this, but in different way. We are going to create a pull request. Look, when we go to, okay, I couldn't do one change. Okay. I did change, I made commits, but I didn't push all the previous 2 changes. So I'm going to push these 2 changes. I'm going to push this to master and I go to, okay, this one is done. Okay, I'm going to check out branch 1 and I push this change to branch 1. Branch 1. Okay, now it shows we have, they gave us an option to create a pull request. I create this button, or we can create a pull request by going here, pull request, new pull request, and we need to merge master branch. Which branch are we need to merge? We need to merge branch 1 to master. So, but all the things are good, but we see this error message. Okay, we can create a pull request. We just create pull request, but it shows, okay, we can't merge it. We can't merge it with GitHub. It shows we have conflict. You can see this conflict where we have this conflict using that button, resolve conflict. It shows you have these changes from branch 1 and you have these changes from master. You can delete, let's say you don't need this change. Actually, this one is something buggy. You don't need something, you don't need this code in your master branch. Okay, you can delete it. You can delete this one and mark it as resolved and commit. But also, let's say you need both of these changes. You can leave it like this and click mark as resolved. This is another, one way of doing resolve the conflicts, but we are not going to do it like this. We are going to use the terminal. I can't remember the branch we are in right now, so I check the branch. Okay, we are in branch 1. We are going to move to master branch, check out master, and we check the branch. Okay, we are in master. Now we need to merge it. Okay, I'm going to merge git merge branch 1, just like the previous previous slide, previous demo. Okay, it gives us error conflict. Okay, when we go to code, it shows our conflicts here. Okay, we can resolve here, same like I showed you previously. We need, in this case, we need both of these lines. I remove this one and key save it, and let's say git status. Okay, we have new changes because we have resolved the conflict. Git add it, git commit it. We can name it as resolve conflict and git push origin master. Okay, we merge it. If we go to the code, leave it. Okay, we don't have pull request anymore, and we have all the changes. Okay, it's a bit messy, okay, but we have the changes. Okay, we have the changes here. We had a conflict, but we managed to resolve it. Okay, these are the commands that you need to run to make a conflict and resolve the conflict. And next thing is git rebasing. I will show you why we need git rebasing in the next demonstration. Okay, rebasing. This previous example was like this. We have a branch, we did some changes. While we are doing changes, someone pushed another commit to the master, and when we were trying to merge it, we got a conflict. When we can use this git rebase. When we run this rebase master command here, it arranges all the commits like this. Okay, yes, it will show conflicts, but it arranges this our commits history, commit tree like this. Okay, then we can merge it. When we are merging it will not show any conflicts because we have to resolve conflicts when we run this rebase master branch, rebase master command. Okay, demonstration. I will show you why first, why we need rebase. If we go to code and commit history here, you can see we have changes 1 from this, changes 2, change from master, but we have this resolve conflict. Actually, this commit is actually don't have any value because it is just we resolve conflicts here. All other things, we have some changes, we have done some valuable code changes. Actually, we don't need this, so that's why we need this rebasing. To do that, I'm going to git branch 2. Same like the previous one. I'm going to check out -b branch 2 and open the code and changes from branch 2. Okay, status git add, git commit, changes from branch 2. I check out the master and I open the code again. Change to from master. Okay. From master. Now we have this problem here. Okay, we have this commit here. I'm going to push all these changes to the master or our remote repository. Push origin master. Okay, I couldn't push the previous code to the master, so I'm going to move to branch 2, git checkout, this one, and git push origin branch 2. Okay, I go here, pull request. Okay, it shows me here the pull request option. Okay, we have conflict. Okay, anyway, I'm going to create a pull request. Okay, now we are going to rebase our branch with master. Git rebase master. Okay, now it shows, okay, we have conflicts here. Okay, we open the code. Okay, we see all the conflicts. Let's say we don't need this changes from master. I delete it, delete these 2 lines. Oh, okay, I change these 2 lines. Okay, now we are ready to go. It shows everything you need to execute. After you finish your, after you resolve your conflicts, you need to git add. And then after git rebase continue. Okay. Now we can push. We need to update our rebase new branch. Use git push origin branch 2. Okay. But it shows me an error because after rebasing means here we have changed the history. Previously the testing branch have this kind of history. We added history like this. We changed the history. So after we change the history, we can't push it like this in usual way. We need to force push, or we can use force or short form -f. I execute it. It push all my new history to the GitHub. Now it automatically changes the it automatically removes the conflict. If I reload this one, it shows, okay, we have one commit. I can use merge pull request or squash and merge. Let's say we have multiple commits, and if we need to make it as one, we can use squash, we can rebase and merge. I will use rebase and merge. Okay, now we have this change from branch 2 here. Okay, okay, cherry pick Actually, I'm already exceeding my time limit. I will leave these. Okay, I will finish this one first. I will. There are few more slides to finish. It's okay. You have all necessary instructions there. I will show you how this cherry pick works. Cherry pick. Let's say you have a testing branch and you have a commit. Let's say you need this commit in after this commit of the login test branch. You can use git cherry pick and hash code. Hash code. What is the hash code? All the time, every time you create, when you are creating a commit, it creates a hash code. You can click it, and this is the hash code. And also in your command line, if you run git log, it will show this hash code. This is the hash code. You have to write git cherry pick like this. You need to go some other branch and run git cherry pick with the hash code. Then it will automatically take that commit and place it after your final commit. Okay. I'm not going to do this demonstration. You guys will be able to uh, follow this instruction and do it yourself. It's very easy. And git stash. I'm going to cover these theories so you guys can follow the instructions and do it by yourself. Stash last changes. Okay. Stashing. Let's say we have change here. Stash this change. We have changes. Let's say we need to hide this change for one moment. We don't need it. We have to work on some other task. Okay, we can just stash it. Okay, we don't have the change. Okay, we stash it. Let's say after we finish all other tasks, we need to work on the previous changes that we were doing. That means we need to get those stashed changes again. Okay, I'm going to git stash apply. Okay, we have the changes again. This is a very useful command when you are doing actual project. And git reset. Let's say you have commit history like this. If you run git reset -- hard head and this tilde mark, then it will remove the last git commit. I will show you git log. I will show you the log here. We have final commit. This is our final commit, change from branch 2. I'm going to delete this commit. Git reset -- hard head tilde. If we use tilde, it removes the first one. If you use 2, it removes last 2 commits. I will use 2. Okay. Now it should remove these 2. Okay, let's see the git log. Our final commit should be this one. Okay, we have the final commit. We have removed 2 commits. Okay. Okay. Also, we can previously we talked about this one, git adding and git committing. Also, we can go to the reverse order. Let's say we have a commit, we can run git reset -- soft head tilde. Then it becomes some changes which are in staging area. Okay, I will show you this one. Git log. We have this commit git reset -- soft head tilde. Now when we this one, oh, git status. Okay, we have it in staging area. If I run git reset, it becomes a change. If we don't need this change, we can run git checkout. Just git checkout and the file name. We don't have it now. Okay. Yeah. I will tell you about the forking. Any questions? You can fire it now. If you guys have any question, you can raise it now regarding this previous slides, because after this slide, I'm going to talk about a little bit about Google Summer of Code, and I'm going to show you how we can contribute to open source, which is very useful. I hope there are no any questions. Okay, okay. Can you explain GitHub Actions? What is the use? Okay, actually, GitHub Action is something else. GitHub Action, actually, this question is very very good question. Actually, I didn't expect this question. Actually, okay, I will quickly explain what is the GitHub Actions. Okay, if you go to your repository, there is a option called GitHub Actions. Let's say in industry, you don't write your code, push it to GitHub, and do deployment manually. Let's say in industry, when we are doing a project, we do changes. We have our test cases that checks our code before we merge it to the master, or before we before we send our code to the live software. We do need to test it. So we have test cases for that, and after every commit, we need to run these test cases to ensure all the ensure that our code is working and the new code doesn't break anything that that was in our code. So GitHub Action, we used to create CI/CD pipelines. That means continuous integration and continuous deployment pipelines. Let's say you you push some code to the master, and we can configure GitHub Actions to task we can create some tasks to test our code, test our test cases, and run it in a virtual server and deploy it automatically in our production server if everything works fine. Actually, this is the brief introduction about GitHub Action. And GitHub Action is whole new topic. Actually, good question. If there is any question, just raise it now, because I'm going to change the topic now. The next topic is, I think, it's really valuable topic. Okay. I assume there's no any questions regarding Git and GitHub. I know you guys, some of you guys have confused about the Git and Git commands. Go through this slide. I will send these slides and get the recording from the Anuradha and refer it. Okay. Oh, how to contribute? How to contribute to open source? I will show you a practical example. Okay. Okay. Let's say we have a repository. Let's say I'm going to check the repositories of Syste. Syste is another open source organization. This is one of their repository. I'm going to their organization page. Okay. These are the repositories they have. We can go to one of their repositories. Let's say this one. Okay. They have their code, commit, number of commit, contributors, everything here. And every organization and every open source repository, they normally mention how they accept their new contributors and new contributions. Okay, so I will go down. Can't find the, because sometimes they might not include the contribution details here, but you will find this one, this chat. This is their communication method. This is the platform they use to communicate with developers. So you can click here and then it will, okay, then it will take you to the communication channel they use to communicate with developers. In this communication, in these channels, you can ask questions about how you can contribute. Actually, in open source world, it is really easy. When you ask a question, they are really kind and they will teach you, or they will direct you to the right place or right documentation to follow, and just go and ask how I can contribute. Actually, when you might think, okay, I don't know much about coding, how can I start? So it was a question that I had previously, but you don't need to worry. Actually, when I was doing my first contribution to Moodle.com, I did very minor changes, like for style changes, like spelling mistakes. I corrected spelling mistakes. Like every contribution is contribution. Doesn't matter it is a big contribution, code contribution, doesn't matter, you need to contribute. They accept every contribution. So okay, I talked about the how we can start communicating. Okay, I will show you how we can push some codes to the open source repository. I am going to Forsage. I will go to Scolabs. Scolab is Sri Lankan organization. Okay, I will get this repository. This repository is their repository. You can't commit like we did in previous demonstrations. You can't just git clone this and git push, because we don't have enough permission. So we need to get a fork. Okay, you might have one option. I have a lot of options here. Okay, I have forked the Scholar / GSOC repository. Okay, now you can clone. Now this code is yours. Now you can clone, you can do changes, and you can push. And after you've done some changes, you can create a pull request to their original repository. Let's say you have done your changes in your master, and you can create a pull request to the Scholar. Then they will see pull request here under, and let's say you have added a new navigation bar, then they will see here with your code, and if the code is fine, they will merge your code to their main code base. That is how it works. In actually, I can't explain everything step by step because I don't have much time here now. Okay, I will go to one more topic. It is GSOC. GSOC means Google Summer of Code. Google Summer of Code. Google Summer of Code is open source. Okay, this is me again. Google Summer of Code is a global contest. It's a competition organized by Google, and it is an annual event. I will be talking about few of these topics. Now, I'm not going through all of these topics. I'm going to explain what is GSOC, the goals of GSOC, and how you can apply. Okay. You guys know about FOSS, so I'm not going to explain this. FOSS is free open source softwares, so you can change the code and you can create customized version of those softwares. So GSOC is Google Summer of Code. They started 2005, and now they have around 607 open source projects there. And now I think these numbers are in 2018. Now I think it might have doubled number, and there's no specific programming language you need to know to contribute, because different organizations have different preferences. They are using different languages, so you can use any language to contribute this program. And you can submit 3 proposals every year, and if you selected to one of these organizations, if your proposal is up to their let's say up to the let's say your proposal is good, you can move forward and you can be selected as a Google Summer of Code student. And the goal in European countries and other countries, actually we don't have summers. In other countries they have summers and they have seasons. So in their summer vacations, most of students, they used to work in coffee shops, other small grocery shops. So they have think that okay, why these technology students, computer science students, why they need to work in grocery shops? So Google has organized this Google Summer of Code to motivate students to the to do open source development, and at the same time they give some money to students so they can pay for their school university fee. So actually this is the main goal of Google Summer of Code. They support students and also they support the open source community by providing new developers. And yeah, this is the main goals of GSOC. And how does GSOC works? Google is the organizer of this program, but under Google there are a lot of open source organizations work with Google, and every organization have mentors. So you are not directly you are not going to work directly for Google, but the organization under Google. Let's say there are a lot of open source organizations in this program. Let's say OpenMRS, Fosacia, Apache, Ruby Foundation, Python Foundation, and a lot more. Previously, there was some Sri Lankan organizations also, WSO2, Scholabs. Scholabs is in the this year competition also. Okay, this is the timeline. Actually, this is the 2018 timeline, but I use this one because it is same every year. Most of the time, they announce the program in September, and they call for mentoring organizations around January, February, and end of February or mid of February, they list all the organizations that has selected to the contest, and then March they open applications for students. So students can go through these organizations, they can read all these project details, and if there is something cool that you, let's say you can let's say you can pull off and give it a shot, you can write a proposal and submit to them. After the deadline of submission, you can, they will announce the selected students, and then after 3 months you have to contribute to their software, and after that they will give you money. The best part of that, okay, best part is money, yes. And you will receive like 3,000 USD. Previously it was 2,400, but I think before 2016 it was 5,000, but somehow they have deducted it to 3,000 for Sri Lankan students and Indian students. My experience, okay. My experience actually, when I was working in Google Summer of Code project, I worked with 3 Indian students who worked in same project, and it is really good experience because before that I haven't worked with any other contributors who are from some other country. Actually, this was a real nice experience, and it gives you really good industrial exposure because every year in Sri Lanka there is around 20-30 students selected to this Google Summer of Code students. So it is like international qualification. So I think it changed my life actually. Yeah, so points note, go for the project that suit your skills. First, you can check the project list. Okay, it is easy. Now you can't send any proposal because now it is June. June. In next year, you can send proposals. You have to start. You can start now, but oops. Sorry for that. I accidentally clicked the stop sharing button. Okay. I just want to make sure that my screen is visible, still visible.
Yes.
Yeah. Okay. Okay. We have one more question, but okay. Thank you for that. Okay. What we were. Okay. Points to discuss. Okay. You have to go to Summer of Code with google.com. Organizations. There are a number of organizations here. All of these organizations are open source organizations. Go to one of these organizations. I will go to Score Labs because it is a Sri Lankan organization. I go to that one. Learn more. View projects. Okay, here you can see what are the technologies they are using, what are the research areas their preferred research areas, topics, under topics. Okay, I got the view projects. These are the selected students this time. I go to idea list. Okay, here they mention all the projects that they have in this year. So you can read one of these project description and go to their GitHub channel and ask questions, and you can go to their projects and do some if you found any bugs, you can report them. Also, you can, if you are if you can correct those bugs, you can create pull requests. And yeah, this is how it works. You can communicate with them and you can ask help from them, and they will definitely help you. But when you are communicating with other organizations, administrators, and mentors, you should use polite way to communicate. So then if you do so, they will definitely help you. So yeah, that's it. That's how you need to do it. And after, you need to write a proper proposal, and you can ask some of your friends to correct your spellings, grammar, and everything. And if you are applying for Google Summer of Code, you can ping me anytime. I can help you. I can review your proposals, no matter. Okay. Yeah, that's it. If you have any question, you can raise again. And thank you, guys. I saw one more question in the chat. Let me answer this one. Okay. Can you give a bit more about version control in Git? Okay. One more question. Okay. To do the Google Summer of Code, you should be a university student. So you have 4 years to complete or apply to the Google Summer of Code. If you are doing your masters, also you can apply for Google Summer of Code. After your 4th year, after you graduated, you can apply for the Google Summer of Code. Okay. Can you give a bit more about the version controls in Git? Yes. We have one more question. Bit more about version control in Git. Okay, but I don't have enough time to explain more about version control system, version controlling with Git, but I will maybe I can share some articles with you so you guys can refer. Can you tell me a little bit about Git hooks? Git hooks, okay. It's interesting. I didn't expect this kind of nice questions here. I really happy to have these questions. Git hooks, okay. You can have GitHub. We have, let's say, I will go to this repository. We have in settings, we have webhooks. So you can connect external services to the GitHub. Let's say, as an example, after you receive one pull request, you need to send a email to someone, or after you receive a pull request or new commit, you need to send a chat message to Slack. So we can trigger some external services using Git hooks. That's why we use these Git hooks to, yeah, in the description also they say webhooks allow you to allow external services to be notified when certain event happen. Let's say you open a pull request and you can trigger some CI/CD tools like Travis, third-party one, or Jenkins to trigger test cases and test your application. Yeah, I hope that answer your question. Any question? Any questions? I'm happy to answer. Yeah, great, cool. Can I assume this is the last question? Can I assume that as my yeah, that as the last question? Okay, I hope that is your last question. Okay, thank you guys. Thank you again for attending the session. I know it is it's strange, some keywords, some, because every time you are learning new language or new technology, it is strange, you can't understand. So just go through my slides and I will share these slides with you and refer the recording, and also I will send you some articles that you can go through, and I hope this presentation helps you, and I hope this presentation will help you in future if you are applying to Google Summer of Code, or if you are contributing to the open source organization. Yes, that's it from my side. So anyone, any questions? If there's no question, we can wrap this session. Yes, we can wrap this session. Thank you guys for attending again, and thank you CIS to give me this chance to do a session after 2 years of the graduation. Okay guys, see you.